Okay, I think we're live. Let me check this out. Properties. That looks good.
I can see us on YouTube, so
Good. Okay. Can you hear us okay on the Twitches and things? Yep. Okay. It seems to be working. Let me know. My audio is seeming pretty quiet, so I just want to make sure. Okay. Welcome. So we have Sourabh Shirhatti on, and it's nice to talk to you. Um, so
thanks for having me, John.
Yeah, so today we're going to be digging into .NET Monitor, but you were mentioning to me you own a few different areas in ASP.NET. So what are your three areas again?
So right now I've been working on servers, so that's still Kestrel, IIS, HTTP server, things like that. I've also been working on observability of the .NET platform all up, so that includes, logging, metrics, like deep diagnostics. And like .NET Monitor actually falls under that purview. And the other favorite thing is just service to service communication, specifically gRPC. So I'm spread a little thin, but that means more chances to come and talk to you, John.
Awesome. Well, I'm happy about it. Okay, I've got not a bunch of links to share today, but there are some deep dive ones. So let's hop on over to that. Um, so here's the list of links. I'll be sharing these out. They'll be in the video description, and I'll share them in the chat as well. So here we go. First of all, Rickster All with a nice post here on handling a single page app fallback paths for a generic ASP.NET Core server. So he has been working with, he's got a hot reload middleware that he works with. And there's this kind of issue you run into with single page applications with both client side and server side routing. So with client-side routing, as you're navigating through, you're actually not making a request back to the server in a lot of cases. You're actually just changing the front end route, and it's actually kind of handling that on the front end. The problem is if you bookmark a URL or if you do a full, Control F5 refresh, then you're going to get a 404. And he's running into that more often with the live reload server. So, you may end up with here as you're navigating through the live application that browsing to albums works, but if you navigate or hard refresh, you get a 404. So he talks about some of the different ways of handling a fallback. And, one way is to use endpoints and just map everything back to index HTML. You still run into issues if you have a missing or here he's going to test HTML. So it doesn't handle everything. So he ends up with a fallback middleware handler. And so it's, I love the whole kind of middleware handling setup and how you can handle just about anything with it. No pun intended, I guess. So here he's got this fallback middleware handler, and that's handling that mapping. So stuff. Speaking of middleware, we have a nice long post going through the ASP.NET Core middleware pipeline from Steve Gordon. And so this starts, building up from the basics, explaining, looking at a basic application and kind of talks building up from the fundamentals. So we're talking about, we've got request delegates. He explains what middleware is and starts with the basics of inline middleware. This is great. With inline middleware, you can just return something. It's very, very nice for kind of lightweight things. And then kind of building up and talking about building up the entire pipeline. And so he goes through that, and he does call out to, he has, full Pluralsight courses that go into this in more detail. So here then he talks about, the application builder and the request delegate pipeline. So just kind of a nice, especially if you're, if you've been just doing the file new project and things generally work, but you're not totally sure how it's all wired together, this is a nice one to kind of take it to the next level and kind of understand that in a little more detail. So and there's a huge amount of power in the in the whole request pipeline and middleware. So, all right, jumping over to a nice fun one. This is a neat one from John Skeet. There's a few things I like about this. One is it's just crazy. He's doing this V drum, so he's doing MIDI drums with Blazor, and he's done some presentations on this. What's also kind of fun with this is, the term blog goes back to weblog, and the initial meaning of it was just a blog, or it was a log of what you were doing, right? So he actually writes this kind of in a log format. Here's Friday 9 p.m. Here's Saturday morning, and he's going through and just talking about it. So you can do quite a bit now. There's the MIDI web specification, and that's relatively well handled. And then also you can do a lot with interop between JavaScript and C#, and there's a good amount as you're going through and handling MIDI. I wouldn't want to, personally, as a much better C# developer than JavaScript developer, I'd rather not be bit twiddling with JavaScript. Or everything's going to end up not a number or truthy, or I don't even know what'll happen. So, so anyhow, this is just a fun read. He goes through and talks about what he's building out. He's got the code available if you've got MIDI equipment and want to try this out. But it's just fun to see. Here he's going through and initializing MIDI. He's iterating through what the MIDI devices he's got and setting different kits. He's got a MIDI drum kit. And just kind of explaining, and here he goes through and publishes the application and does a presentation on it. So this is pretty cool. So if you do have a suitable Roland instrument, you can try it out yourself at VDrum Explorer, John Skeet UK. So and here he says it's it's not on GitHub yet, but will be quite soon. All right, so changing gears a bit here, this is a very light, just fun series on game dev, 2D game dev in Blazor from Dahveed. And here, this is part 3. These are just little bite-sized chunks. So here he's going through, this is the third one in a series, and he's just doing simple things like canvas and sprites. So each of these posts you can read through in just a few minutes. And, here he's just talking about things like initializing canvas and using sprite management and stuff. So some cool stuff. And as he calls out in the first one here, he originally, decades ago got into programming because of game development. I know that was some of my first early programming stuff was, writing silly little games in BASIC. And it is a fun way to get into and learn new programming stuff. So cool. All right. Now we get to the big one. This is the, okay, so here actually, there is a performance improvements in .NET. And it's actually such a big post that I have 3 bookmarks on it. So there's I'll jump up to the top, but this is Stephen Taub. He's been doing these yearly, and he just goes through for the major releases and talks about all the benchmarks and all the performance improvements. It's fun because these includes the information on how to actually run these yourself and how to test these benchmarks out. And what I love about .NET, what he shows in here, and just in general, what I love about .NET performance improvements is they ripple all through the stack. So when something improves in text processing, that affects my, Kestrel, and that affects my JSON performance, etc. So, so here's some things that I kind of want to call out to for ASP.NET devs. So one is text processing. And Sourabh, feel free to jump in if there's anything you see that's interesting here. I know you kind of get into this stuff. A lot of web dev and a lot of what Kestrel does and a lot of what ASP.NET does is text processing. You've got text coming in, you've got you're parsing headers, you're parsing request cookies and all this stuff, and then you're concatenating a bunch of strings and you're sending text back out to the browser. So text performance is really important. So here there's just a lot of neat stuff. earlier on and throughout this post, there's a lot that goes into explaining things like using more hardware intrinsics and just continuing to like say, hey, can we jump out of this code? Do we need to, if we're checking bounds 3 times, we can just do it once, etc. He does in this area, he talks about the UTF-8 formatter and also the Latin encoding, so Latin 1. And both of these are used quite a bit in things like parsing headers. And so just it's fun to look at these, going from 221 to 41 for nanoseconds for some of these benchmarks. In a lot of cases, too, there's things like you'll see also called out in here, vectorization. And a lot of the time, there's a big difference in allocation as well, which is really cool. Regular expressions, again, this is something where, if you're figuring out is something an email address, is something a URL, regular expression performance is really important. So text processing, pretty cool. Networking, of course, huge, right? And so this is neat looking at some of the things. And again, look at this allocation, 1/5 as much in the constructor for URI, just continual, of course, parsing out path and query in a URI is something in an ASP.NET app, and then again in service code that you're going to be doing all the time. And so it's cool to see, things like that just continue to get better. And again, you don't have to do anything to use this stuff. You get on the newest .NET Core 5 and you just get this stuff for free. So that's neat. One other one I wanted to point out is JSON. So system text JSON has a bunch of cool stuff, including improvements, like for instance, for the JSON serializer. So again, just this is just fun, man. Look at going from 24K down to 152 bytes. So I don't know. I love geeking out over this. This is a long read. This is, I think a lot of this stuff is going to be over you're not going to know all this stuff, but it's just fun. So I love reading through these. And then again, there's a fun part way down at the end that he calls peanut butter. And the idea here is it's just stuff that's spread all across .NET in general. So things like faster math, faster assembly loading, faster crypto, all of these things are things that help all of us. And my final thing that I love about this post is you'll see all these credits given out. So these are people in the community. These are people, working at other companies. There's ARM work in here that was contributed by, developers at other companies, just tons of cool stuff. So anyway, I just love this post, and I read through it. And I'm going to read through it again a few more times because there's a lot in there. And then the final post I'm just including because I think we'll go into it in more detail, Sourabh, as you talk about things. But this is the post that you recently posted about dotnet-monitor. So that's some fun stuff just on dotnet-monitor. But I think it'll be fun if you just want to dig into it and show us what it is.
Right. So I think I'll actually cover a lot of content covered in that post.
Cool.
Oh, you can hear me okay.
Yep, you're live, you're on.
It's a little trippy because the only video feed I have is the YouTube channel, so it's about 15 seconds behind.
Yeah, there's a little bit less latency on Twitch if you want to watch there, and then I'll be watching I'll feed you questions off the chat.
Okay, so yeah, just talking about dotnet-monitor, we actually ship it in 2 form factors. So it ships as a .NET Global tool. So you can use it locally, you can use it on a remote machine, you can use it anywhere where you traditionally use .NET. But the other fun thing that we've done is we've also packaged it up as a container image. So it's an artifact available on Microsoft Container Registry. So you can go and actually pull the image down and deploy it as a sidecar alongside, say, your .NET application in a cluster or something like that. So
now, can you clarify that term? What do you mean by sidecar?
Okay, so there's a pattern. So I'll use Kubernetes because it seems to be the orchestrator everyone uses. The unit of deployment that you should think about is a pod, right? And a pod can be comprised of multiple containers, but there's some guarantees the orchestrator gives you, like, hey, like all containers in the pod, one, they share the same network namespace. Two, they will be co-located on the same physical node. So there are a couple of guarantees. So a common pattern is for concerns that are relevant to your application, but not necessarily solved by your application code, like diagnostics, logging. Those are common patterns. Or service mesh is another one. But what you do is you're like, hey, I will deploy another container alongside my application container in the same pod, right? And those containers are usually referred to as sidecar containers.
Okay.
So in our case, what we're trying to do is we want to make it easier to get access to diagnostic artifacts, right? We want easier access to metrics, to logs, to process dumps, to traces. So I'll take traces as an example. You want the ability to collect a trace from your application, but it's not necessarily your application's concern, right? So sidecar is a great pattern. You deploy something alongside your application, and it exposes some API surface that when you want to collect a trace, you talk directly to the sidecar. So there's like the separation of concerns. And when you write code, you don't have to be aware or think of, hey, how can I make my application aware so that it can be traced?
Okay.
Right. So what I'm going to do is I'm actually, let me start sharing my screen and then let me know when you can see it.
Yep, I see it.
Okay, awesome. So what I'm going to do is first I've actually acquired the tool locally. So I will show you that it can be used locally, and then we'll look at the in-cluster scenario as well, right? So just so we can show people, right now this is still on our like DNC eng package feed. So this isn't quite yet pushed to NuGet.org, but the link is in the blog post. So if you want to go get started, you can do this. So I've already done this on my machine and I've installed the preview. So if I go ahead over here, let's do this. Is my font size large enough?
No, you should blow that up.
Okay, let's do this. So I have dotnet-monitor installed locally. You can see that it has one verb that it ships with called collect. So if I go ahead and do dotnet-monitor collect, it actually starts up a web server. So now this is interesting. So let's actually go over to the endpoint exposed by this, right, and see what's actually exposed. So if I go over here, you'll see nothing is exposed at the root. That's okay. The 404 is expected, but there are a couple of endpoints. And first, let's look through what it exposes. So obviously, for any of these like diagnostic operations, first we need to know what process we want to target, right? So it does expose a processes endpoint.
Mm-hmm.
And you can see right now it shows me just like the PIDs. So these are like when I make an operation like say collect a process dump, I would want to specify what PID. It is a little smart in that if there is only one target process detected, then you don't need to specify what PID. And that turns out to be super useful in the context of a pod, because you usually only have one instance of an application container. So I'll show that in a bit. But here you can see I have a couple. We are actually making some improvements. So this should be coming soon, where you can actually see the command line associated with the PID. Because right now, if I had to choose what PID to perform an operation on, this doesn't really help me because I don't know the PID, right?
Mm-hmm.
Fortunately for me, I'm going to drop to the command line. We have some other tools. So if I just did, there you go. I do this, I can actually see what are the PIDs. So I happen to have like NuGet Package Explorer, and I want to showcase that these diagnostic tools are applicable not
Can you
only to
bump up
web
the
apps.
font again?
Oh,
Sorry.
sorry. Yeah. These diagnostic tools work not only with applications that you write, but anything that uses .NET Core. So in our case, like in my computer, I'm running NuGet Package Explorer, and you can see that it's also a .NET Core app. So I'm able to detect it. So it was also in this list of processes, right? So now using some of the endpoints included. So if I go to /dump/pid, right? So this is NuGet Package Explorer. If you actually look down here, I actually just hit the diagnostic endpoint, and that went and collected a process dump of NuGet Package Explorer.
Whoa.
The other thing I can do is, so I can just hop back over to the blog post and show you what are the endpoints that we're going to be looking at. So these are the endpoints. We have dump that allows you to collect a process dump. Each of these have a little more options on them, like you can specify, the type of dump, or in the case of traces, which providers. But we have dump, which is a full process dump. We have this diagnostic artifact called a GC dump. It's something I've blogged about before, where it's basically by instrumenting the GC, like when a GC operation occurs, we actually emit events, and through those events, we can construct an object graph of all objects on the heap. So you can't necessarily see like field values, but you can see the graph of all objects. So this is a lightweight artifact, like a GC dump, lightweight artifact that gives you visibility onto what's going on in the heap without the expense of a full process dump. So it's a much smaller artifact, and it's also a more portable artifact. It isn't tied to the OS, and there aren't restrictions on how you can consume it. So the endpoints we expose are the dump endpoint, the GC dump. We have trace, and when you don't specify anything, the trace includes a CPU profiler, so you get managed stacks. You also get events for HTTP request start and end, but you also have the ability to enable any event source provider. And then we also have an endpoint that allows you to stream back logs. So your, Microsoft extensions, iLogger logs, the ones that you're used to in your web application, can be streamed out. And we have a last endpoint that allows you to see a snapshot of the metrics. So we'll go over each of them, but what I wanted to showcase now is this is applicable both. What I showed you right now is I was using it locally to collect a process dump. I could even do it on a remote machine. Right? Let's say it was a secure network. I could run dotnet-monitor on a remote machine and then use it to collect like a diagnostic artifacts from that machine. If you want to do anything more than that, like the onus is on you to secure it. So we're not trying to solve that just yet, but we will be interested to see how people use it and what kinds of problems they solve. And that's actually a lot of the feedback we're trying to solicit right now as we're looking for future investments.
Okay, I have a question that I'm not exactly sure to ask. Hopefully you'll get the idea and figure it out from what I'm saying. At what level does .NET Monitor hook into things? So like if I've got multiple things, you showed like NuGet Package Explorer, which is a desktop app, right? And you've got multiple different processes instrumented. Is everything kind of registering with that, or?
So that's actually an awesome question. So what we've been doing starting from, I want to say .NET Core 2.1, is we introduced this abstraction. So we already had this abstraction called event source in the runtime, right? And event source events were egressed in the case of like when we were Windows only, were egressed ETW. When .NET Core went cross-platform, we started egressing these to LTTNG as well. So these are like user-defined trace points. But the goal was always, because we had an abstraction, right? Like when you emit event source events, you're not tied to Windows or you're not tied to LTTNG. So having that abstraction let us expand different collection mechanisms. So what we've done in recent releases is the .NET Core runtime actually exposes a diagnostic server, right? And this diagnostic server listens on a platform native transport. So in the case of Windows, it would be a named pipe. And in the case of like Macro Linux, this is a Unix domain socket. And now, as the name diagnostic server suggests, it is a server. So it speaks a request response protocol. So that is something I can actually hop over to the .NET Diagnostics repo, and that actual IPC protocol is documented here. It is, it's over here. So if anyone's curious on the exact IPC protocol, it's actually documented here. So you see, so any client can connect to the runtime and send a diagnostics IPC message, and then the runtime will continue to stream back data.
Okay. I guess, part of the thing with this is now with .NET being so like you could have multiple different versions of it running. It's so kind of distributed and broken apart that, I could have multiple different, like I could have things running in containers and all that. So basically, I could potentially have more than one of these diagnostic servers running on a machine, and they're just all registering with whichever ones they would want to. Does that make sense?
Uh, I'll paraphrase, but I would have hopefully answered your question. Every .NET Core application, I'm going to say 3.1 and above because there are some like variations. Every .NET Core application 3.1 and above always has a diagnostic server it's listening to.
Got it. Okay.
So any .NET process has the server, and then your diagnostic tool. So in this case, that would be your client. Each of your any client can connect to any .NET server on the process, provided you have permissions, and then request at the runtime egress information.
Oh, okay. And then last question before I let you get back into it. What's the overhead on this? Is this affecting performance if I'm connecting in? Or?
So if I go back to, let me answer in the context of .NET Monitor, mm-hmm. and then that's more broadly applicable to just uses of the diagnostic server.
Okay.
There is no observable overhead when you are not asking the runtime to egress information.
Okay.
Right. So if it's just sitting there, the server, there is no overhead. Now we care about perf obviously, and we run tech and power benchmarks locally. So in our infrastructure, and I think Sebastian's come and talked about this on the show as well, we actually collect metrics. The mechanism that we use to collect metrics, even in our perf test, is the same mechanism. We actually talk to the diagnostic server in the runtime and ask it to egress these events. So for what we've recorded is, for something low overhead like metrics, there's no visible performance impact. Now, obviously, if you go to the point where you are, say, CPU sampling, mm-hmm. then there's a huge performance impact, because what we have to do is, I think the default frequency is we collect a CPU sample every 1 millisecond. So every 1 millisecond, we have to pause all your threads, synchronize them, then walk each stack and write an event, and then let the execution continue. Mm-hmm. So based on the kind of diagnostic operation you perform, there will be an overhead. But the goal that we want to, our desired state is, when you're not actively egressing information, there's no observable impact.
Okay. I have one other question from the chat, which is whether there are security risks or DDoS, concerns on this.
So yes, like anytime you're talking to the runtime, there are some considerations. So I think I mentioned before is we listen on a platform native transport. So the nice thing about both Windows namepipes and Unix domain sockets is they use file descriptors, or I guess in the case in Windows too, I guess file descriptors. That also means you can ACL them and restrict access like you could to files. So it really comes down to, if I have permissions to access your application and execute your application, only then can I connect to the diagnostic server.
Okay.
We have a couple more, we're looking at certain patterns, like in .NET 5, we're actually adding this feature, or we've just added it, where the runtime can not only act as the server, it can act as a client. So your diagnostic tool could be the server, and your application, when it starts up, will connect out to your diagnostic tool and send event. So it's like we flip the polarity, right? Mm. And that's useful for scenarios like startup tracing, because in the current pattern, it's hard to do startup tracing. So when we add new functionality where none of that is opt-in, and we're gating it behind knobs, so it's a very explicit gesture you have to make. But it's a great question, and you have to be cognizant of that, and make sure you make a determination based on your use case. Okay. One thing that I will talk to in the case of .NET Monitor, actually, I think this is a perfect segue. If I go back to the endpoints exposed by .NET Monitor, right? What we have done when we did a security evaluation and we did threat modeling, we said, hey, all of these endpoints, so starting from dumps, GC dumps, traces, and logs, they actually can egress information that could be sensitive to your application. So what we're going to do is the .NET Monitor process actually binds to two different ports. So it has a port that only exposes the metrics endpoint. Why? Because we made the determination that metrics are safe to expose. And in fact, that's a common pattern, right? People use tools like Prometheus to scrape metrics that are exposed on the endpoint. So for the rest of these operations, very much so, they expose sensitive data and should not be like exposed obviously to the internet, but even in the context of, say, in your cluster, you don't know if you're, I mean, it depends if it's a hostile multi-tenant scenario or not. But even then, the recommendation would be do not expose these endpoints to other tenants.
Okay. Okay, that makes sense.
So
then I guess as you're talking about exposing things and stuff, you said they're controlled by ACL. Is this something where I'm going in manually and configuring all this, or how? And
okay,
you'll probably show this, so I'll stop.
Yeah, okay. No, these are good questions. I actually like the flow because it's
Okay.
a natural progression. So there are actually two things that I want to like tease apart. There is the diagnostic server and the runtime, which is the technology underpinnings of how .NET Monitor works, and there's .NET Monitor itself, right? So let me answer the question in the context of the diagnostic server first. The diagnostic server uses the same ACLs as your application does. So if I was to go into details, in the case of Linux and Mac OS, we create a Unix domain socket in the temp directory. Now the permissions, and I think in the case of Mac OS, we actually set ACLs on that directory. So the common pattern for the temp directory is anyone can create a file in there, and everyone else can see it but can't modify it.
Okay.
So the way the tool works, right? So the way .NET Monitor, or in fact any of the other CLI tools we have, like .NET Counters or .NET Trace work, is they actually query the temp directory for all these diagnostic pipes.
Okay.
In the case of Windows, the name socket, all name pipes are there is no like directory hierarchy. So all name pipes are created in the root of the name pipe file system, and then we just query for it there.
Okay.
But like if I'm user foo who's running the application, I can't talk to the pipe unless I have permissions for user foo.
Okay.
Now, in the context of .NET Monitor, because we're actually, so as to speak, creating an HTTP proxy for the diagnostic server, right? Not quite. We've actually made convenience methods. But because it's an HTTP endpoint, anyone who can access the HTTP endpoint can now access this diagnostic data. So you have to be careful on how you expose it. So I will show you the Kubernetes use case, and that'll kind of give you an example. It also leads to one other thing that we're actually trying to get feedback on. So everything I'm showing you about .NET Monitor today is what is useful for ad hoc analysis, right? This is at the point where you've ascertained there's a problem and you're like, hey, I need a diagnostic tool I could use to collect data when I already know there's a problem. So that's what I call manual triggering. We understand the manual triggering is only one of like a multitude of use cases. So obviously there could be something in the future where, like, say, John, you go, hey, I want to collect a process dump, but I don't want to have to do it manually. Every time my CPU utilization goes beyond 75%, I want the ability to collect a process dump, right? So this notion of triggers based on other either metrics or other diagnostic data is something that we're working on. So that also helps alleviate some of the security issues where those heuristics that you defined for collecting this data like are like a deployment artifact, and then where the diagnostic artifacts are written to are something that you can secure. So no one has to talk to the runtime directly. So that's another mitigation that we could get to in the future, say.
Okay.
So what I'm going to do is I'm going to real quickly show you this tab. So like I said, .NET Monitor ships both as a global tool as well as an image. So you can see I'm on Docker Hub and I'm on the .NET. It's the nightly images. So like I said, we're still in preview. So this right now ships only as a nightly image. But as this project matures, we will ship it as under mcr.microsoft.com/.net/monitor. So right now we have one image and it has the tag of 50. So you would do Docker pull this if you wanted to use it. So I will just quickly reference the blog post. There is instructions on how to run locally in Docker, but I'm actually going to skip this and head over to the Kubernetes part because that's the interesting thing. So let me go over to my Kubernetes deployment file. So nothing here should be too interesting, but let me just walk through what I'm doing here. And there are certain parts I'll come back. So I have a deployment, and this deployment, if I go under the containers, is comprised of two containers. One is my server container, and the other is my sidecar container, right? So this is what I meant by sidecars. These are two containers in the same pod.
Okay.
My server container, in this case, I've just deployed a sample ASP.NET app. I mean, in your, like when someone's recreating this, they would probably want to deploy their application.
Okay. Can you zoom this in again? Yeah, that helps. Thanks.
Thanks for the timely reminders. Yeah. Okay, so I have my server container and my sidecar container. So my server container is a web application and it's listening on port 80, right?
Mm-hmm.
Nothing out of the ordinary there. And then I have my sidecar container and it's listening on, so it's exposing port 52325, right? If you actually look closely at the next line, you can see that there's a URLs it takes and a metrics URLs. So this is what I spoke about. So the only port that we're exposing right now is the metrics URL. It also has another URL for deep diagnostics artifacts that we aren't exposing yet. So I'll show you how to get to that.
Okay.
And the only other thing about configuration right now is I've created this volume called the diagnostics volume. It's unfortunate that when I mouse over, it gives me tooltip text, which I don't want right now. So I've mounted the diagnostics volume in the temp directory, both in my server container as well as my sidecar container, right?
Okay.
So this is what I was talking about. The Unix domain socket is created in the temp directory. Now, with all that said, I'm going to go ahead and run my application. So let me do. Let's go over here and do get. So I'm just waiting. This is just Kubernetes get pods with the dash wait. Oh, it looks like it already terminated and finished running. So cool. So I have my pods running right now. Given that this is a new cluster, I haven't quite set up an ingress resource yet. So I'm going to do a neat little trick where I'm going to say, okay, port forward. I'll do pod / name of the pod, and I'll say port 7000 maps to port 80 inside the container, inside that pod. This shouldn't normally be required. I'm only doing it because I haven't set up an ingress resource. It's a new cluster. So now if I go over to, let me close some of these tabs. Localhost, was that 7000? Did I pick? Okay, there you go. So this is my application running, right? Nothing fancy. This is a regular ASP.NET application. You can see, there's some, it's .NET Core 3.1.5 running on like Linux kernel version 4.15, right? And just some basic information. Now, the other thing I'm going to do is I'm actually going to forward traffic to another port. So let me do port forward. And I'm going to map port 7001 on my local machine to 52323. So remember, this is a port that wasn't
52325, I think.
right. So that was the metrics one. I want to show this.
Oh, got it. Sorry.
So this port wasn't actually exposed, right? So like think of this scenario and I'm in right now. I'm like, hey, my application that I just showed you, right? This one, there's something wrong with it. I want to go collect a process dump. How do I do that?
Got
So
it.
at this point, for me to be able to run this command, I am a cluster administrator that I can just randomly forward traffic into any port. So this already is a huge like security requirement, right? But now that I've done this, if I go back here and let me hit localhost 7001 and let me hit the processes endpoint. So you see, I only see one process with PID1 running, right? And remember the thing I told you about, there's a convenience method when there's only one process ID. I don't have to specify anything.
Ah, nice. Yeah.
So now if I go ahead and hit /dump, like it's going to take a second because it's a streaming endpoint, but let this just sink in. There you go. So it took a while, right? It had to trigger browser. But I'm on a Windows machine. I was able to make an HTTP GET request, and that triggered the collection of a dump. And this is in cluster in Kubernetes, and I just got a Linux core dump.
Wow. Okay, so you didn't have to map 52323. Is that because of a star mapping in the
No, so there are two things, right? One is, did my application bind to that port? So dotnet-monitor did bind to that port, and that was specified in the configuration if you see here.
Oh, that was 323. Okay, sorry. Yeah.
What I didn't do is I didn't expose it using a Kubernetes primitive, because if I expose this, right, even if I don't have an ingress resource, another service, say this is, .NET Hello World, .NET bad application is also deployed in the same cluster and could actually access this endpoint and do like smart things with it.
You could traverse across if there was a insecure app, you could get across to this one.
Right. So don't like, unless you're going to do some sort of like TLS mutual auth and secure that endpoint, please never expose the URL. You can expose the metric URL, and I'll show that in a second. So I was able to collect a dump. I'll show a couple more things. Let me show you the trace endpoint, right? So this is the one I told you enables the CPU profiler and collect traces. So it's currently a streaming thing. So I'm going to go make some requests, right? I'm going to make some requests to put some synthetic traffic into this. The default duration of this trace is 30 seconds. So let me go and synthesize some traffic for, a little while. And you can see it's just streaming that out. I thought it would be easier to dock for 30 seconds, but this seems to be.
You could click on the home and privacy links, right?
I was doing F5. I don't know if it was apparent in the process. Okay, so sweet. I have this net trace. Now, the cool thing about this, again, is you see it actually shows the Visual Studio icon. If I go ahead and open this, again, let this sink in. I just collected a CPU trace from inside a cluster that's running Linux, and I'm able to open this in Visual Studio. Oh shoot, did not realize I just updated Visual Studio. So we can let this run for a second, and I will show you the other one, and I'll get back to this when Visual Studio is done.
So, let me show you. One question, if we need to, it seems like now's the time to ask. For those dump files, for people that aren't familiar with that, what's the best way to actually open and work with a dump?
So there was something I really wished I could show, but I couldn't just yet. So these are, this dump file is a Linux elf dump. So we have a tool called Dotnet Dump, right? That's the command line tool that allows you to collect a dump. It also has a hosted REPL. So if you do .NET Dump analyze and point it at a core dump, it can analyze the core dump. Now, a limitation that we had was, because of the nature of how the runtime and the DAC is built, you could only analyze a dump file on a machine that has the same same DAC. So it basically has to be the same OS, Bitness architecture, and libc version. So I actually mentioned this in the blog post, which is sorry, here. You can run a Docker container. So you can Docker run and then analyze it using .NET Dump. But the other thing that I'm super excited to share and is that we have recently, so we have this component in the runtime called the DAC. That's the data access component, right? We've actually just managed to cross compile the Linux DAC on Windows, which means very shortly we're going to push an update to the .NET Dump tool that will allow you to analyze or run like SOS commands on Linux dumps from Windows.
Wow. Oh, that's really useful.
So that's coming really soon.
Okay.
But for now, I would say the easiest way to do it is just Docker run and use something that has the same base image as the platform it was collected on, and then you can analyze. So in the context of the first dump I collected, remember that was just a dump on Windows of like NuGet Package Manager. That can be analyzed right away because it's already the same OS architecture Bitness.
Okay.
Oh yeah, sorry, that's what I almost forgot what I was showing. Okay, so here you can see I have, this is my sampled CPU stacks. So I'm able to see things like, it already shows me the hot path. I don't think there was anything interesting so as to show. And it also has this events viewer. So I will just scroll down till I see a couple of interesting ones, right? So we have, these are all the sample profilers. I wanted to show the metrics. How do I do this? Okay, there you go. Let me do this. So I want to say we collect a couple more events. So this also has, you see the value of these event counters at certain durations. So we are working on some functionality in Visual Studio where like all the CPU samples are interesting. What would be even cooler is you could say, hey, there's a graph, like just plot my CPU usage. And then I only want to see like I want to do a time slice and only see stuff based on the event value. So that's some functionality that we're about to add. But the good thing is, our tool and Visual Studio are already on the same page. So we're already egressing that correct information.
Okay.
So there's also the GC dump, and let me skip that in the interest of time. And let me show you the other fun one. Let me dial this side by side so you can actually see it. And so I have my here. And then remember I said we have a logs endpoint. So same, the logger logs that you're used to. Now if I go make some requests and stuff, you can see it's actually streaming out logs.
Okay, that is hugely useful. Like the other things I can see for digging into a performance issue or whatever, this seems like something where I would more often run into, where it's like, why is this whatever, some weird access issue for a file or something? Yeah, this looks great.
So this is streaming. You can see it's just continuing stream. The other thing is, if you look at the logs, these are actually like debug logs I'm seeing in here. So the verbosity of logs, I forget the query parameter. I think it's level, but I don't want anyone to quote me on it. I can clarify later. You can specify a verbosity that's higher than say what you did in your app settings.json file. So if you really, for an ad hoc investigation, want to momentarily turn up the log level, you totally can do that.
So you can momentarily, or you can, for a short time, bump that up via query string, and then you would bump it back down, and it's just going to change the logs in circular.
Sorry, this only, so the query string parameter only impacts the log level that you're seeing here in the streaming response.
Okay.
If you had like an app settings.json file that was like, say, writing to console or writing to some other log provider, that log level is not affected.
Okay.
So that's what you want, right? You want your always on pipelines to continue to do what they always did, and your ad hoc analysis give you the ability to turn it up.
Okay.
And then the last endpoint I wanted to show was the metrics endpoint, right? So if this looks familiar, or even if it doesn't, this is actually metrics exposed in the Prometheus style, the Prometheus exposition format. So we have the metric name, we have the friendly name, and we have it defined as a gauge, and then we have the last three samples, right?
Okay.
So the cool thing about exposing metrics in the Prometheus exposition format is you can point a tool like Prometheus, or say if you're in AKS, like Azure Monitor, to say, look, I expose metrics in a standard format. Can you please scrape my metrics? So if I go back to my definition, I just want to make sure people notice that I actually did expose this, right? I did expose this endpoint. So the other thing is, so this is how you normally configure Prometheus or other things, is via annotations, right? And this is awesome. All I had to do is once I added the sidecar, right, to get metrics, I didn't have to write a single line of code. I just had to say, hey, Prometheus scrape equals true, and the port that I'm exposing is 52325. There's also the path, but I think when not specified, it defaults to /metric, so it works in our case.
Okay.
And so what I have done in the case of my demo, like I don't know if it was apparent, but I've actually deployed to AKS, the Kubernetes cluster I was running on. So the other thing I was able to do is this like annotation is understood not only by Prometheus, actually what is it? Azure Container Insights also understands these annotations. So what I had to do is I had to slightly update my, this is the config map that powers the configuration for the Azure Monitor. And I had to say, there was this. So I set the interval equals 1 minute, and I told it to monitor Kubernetes pods. So if you can see the comment right above it, when monitor Kubernetes pods is true, it will enable scraping. There's the scheme, the path, and the port, right? So one cool thing I can show you is like, while we've been talking, I've been letting this thing run. So if I hop over, let me close this. If I hop over into my cluster, so this is my Kubernetes cluster, right? This is in Azure. This is a tad bit slow, but if I hop over into my logs, let me just make sure. That would be extremely unfortunate if there's like the portal is down right about now. Oh, maybe it's just like a auth thing. Okay, let's give it a second. I do have my query that I want to copy over from here, so I'll go pull that up in a second.
Okay.
I have this query that I wanted to showcase. Okay, this is unfortunate.
Well, while it's doing that, maybe to give it a chance to load, is there any relation or overlap, or how does this fit in with like Project Tie? Because I notice here you're manually configuring Kubernetes and stuff. Is there a way to integrate this with Project Tie work so that, maybe I'm instrumenting my application,
Right. So there are a couple of things to note. So Tie today uses the same mechanism. So if you've actually used Tie, like, the thing where on the Tie dashboard, if you click on the process name and you can see metrics or see the live streaming logs, that is actually using the same mechanism. It talks to the diagnostic server. So there is this shared tech. So like right now we are like, I'm working with Justin, I'm working with John, and we're trying to figure out how do we fully like integrate this, because Tie is an excellent experience in the inner loop. Like I don't think .NET Monitor would give you as cohesive of an experience when you're just deving your services. But in the production scenario, like it's definitely something we should explore on whether Tie should deploy this sidecar for you. I think in terms of like maturity of the project, Tie is a little further along in the maturity ladder.
Okay.
So it probably can't take dependence on something that's lower along the maturity ladder. But if this goes from a committed experiment to a long-term supported product, That's absolutely something on our roadmap.
Cool. Yeah, it seems like that exactly like you're talking about, like the Thai dashboard, and then having more kind of knobs and things where I could do across my application without needing to go in manually.
And I mean, like the diagnostic server bit, which is in the runtime, is here to stay. We already have supported CLI tooling. Thai uses it, dotnet-monitor uses it. A lot of things can use it. So that will definitely like survive all of us.
Yeah, cool.
And so looks like .NET, the portal just loaded. I don't know if there was like some outage. Hopefully this query completes. But what I'm saying is because I had enabled monitoring of, like I had enabled this. I kind of keep tripping up on the name because I had enabled this. Azure Container Insights was actually scraping my container. So it scrapes it every minute, collects the last 3 samples, and I'm actually running a query and plotting a time chart of like the allocation rate. So
well, it does that. I mean, if just filling time a bit, but so can you explain that syntax of that query a bit? So, I mean, I guess it's pretty SQL-ish.
This is the Gusto syntax.
Oh, right. Okay.
So this is just the anything that it scrapes using the annotations is put in this namespace Prometheus, right? And I'm just filtering down to my app, and I have a bunch of metrics. If we go back to the actual metrics endpoint, if I still have it open, they're all. So I'm exposing like I think 18 system runtime metrics and then Microsoft ASP.NET Core metrics. So what I was just trying to do is I was just trying to plot one of them. Allocation rate is actually a pretty nice one to plot. Let me try this. Let me filter to last 30 minutes. That might make the query execute a little faster. I've been using the same like cluster for a while and playing around with this. So there might be a lot of data. There's also there's definitely some sort of like service outage or my network failing to connect to Azure right now, because this normally takes about 11 or 12 seconds.
Okay.
Funny thing is I tried it a couple of times before. Okay, so that's not good. There you go.
Now it's like instant.
Yeah, no idea, because that took like, what, 5 seconds? Oh, there you go, like
0.3 seconds. Yeah, 0.4.
Yeah, it shouldn't have taken that long. But there you can see, I can see like my metrics are already in Container Insights, and then I can do stuff like alerting on these metrics. So this is awesome stuff.
Oh, right. And that's huge, right? Like you're saying, being able to alert or scale or do all kinds of automation based on that.
Right.
Wow.
So that's all I had to show for today, but we're definitely interested in how people are using it, or so if folks are interested, they have suggestions, questions, I'm going to take them to a link, which is the .NET Diagnostics repo.
Okay.
So all the development, maybe something with my internet, like everything seems to be down. Like I can't hit GitHub right now. Is the .NET Diagnostics repo. All our work happens in here. So come here, file an issue here. We'll be happy to chat about .NET Monitor. And if not, folks can find me on Twitter or just shoot an email, and I'd love to talk more about this.
Great. Okay, I will include this link on the stand-up links that I shared earlier, and then we also have your blog post too that kind of overview some of this if people want to play along at home. So. Wow, this is great, Sourabh. Thank you for your time and perfect timing. I mean, it's right at an hour, so excellent.
I definitely did reverse it to the hour, but it worked out, I guess.
You're a pro. All right. Well, so we now have, I don't know if you remember the dramatic zoom out effect. We used to have on old shows, we would do a dramatic zoom out. Damien would press the remote and zoom out on the camera. And through complicated science things, I have now mostly replicated that. So if you're ready, it's time for the dramatic zoom out.
Sure.
Okay, so brace yourself because you may actually be thrown across the room as this happens. You ready? Here we go.
All right, let's go.
And